Electroencephalogram Eeg, its processing and feature extraction. Abstract. This paper deals with the basics about electroencephalogram, its processing and feature extract ions. Prominently used extraction methods such as principal component analysis, independent component analysis, time-frequency analysis, wavelet transform have been discussed here along with mathematical representations. Software tools and their use towards EEG are highlighted. Keywords: electroencephalogram, tests, waves, processing, feature extract ions, mean, standard deviation, power, variance, skewness, software tools. Introduction. An electroencephalogram, EEG, is a medical routine that detects abnormalities in the brain waves, or in the electrical activity of the brain. During the test, electrodes are pasted onto the scalp of the patient. These electrodes are tiny metal discs with thin wires connected to the acquisition system, and they detect tiny electrical charges that result from the activity of the brain cells. This is then amplified and appears as a graph on the computer screen, or as a hard copy recording. The doctor/technician then interprets the reading. 1. The EEG test is performed by an electroencephalogram technologist. It is done in the following way. 2. You lie on your back on a bed or in a reclining chair. Flat metal discs called electrodes are placed all over your scalp. The discs are held in place with a sticky paste. The wires protruding out of them connect to the acquisition system. This system converts the recording/signals into EEG patterns that can be viewed on screen or printed onto a sheet of paper. These patterns look like wavy lines. You need to lie still during the test with your eyes closed. This is because movement can change the results. You may be asked to do certain things during the test, such as breathe fast and deeply for several minutes or look at a bright flashing light. You may be asked to sleep during the test. Depending on the kind of activity and hence the frequency range it falls in, the EEG wave can be classified into beta, alpha, theta, delta, and gamma waves. Their frequency ranges are as follows: 3. Sahana, Sundar, Raman, Lakshmi A.S., Prerana, Ananda, Murthy, Mohammed, Faizan, Department of Medical Electronics, Ananda, Sagar, College of Engineering, Bangalore, India. Waveform frequency range activity. Beta 1330 Hz highly active brain activity and conversations. Alpha 8 to 13 Hz very relaxed. Deepening into meditation. Theta 4 to 8 Hz drowsy and drifting into sleep and dream. Delta 0.1 to 4 Hz deep sleep with no dream. Gamma 30 to 100 Hz hyper brain activity, great for learning. 2 Advantages of EEG. The advantages of EEG include 4. 1. Functionally fast and are relatively cheap and safe method of analyzing the functionality of the brain. 2. High precision time measurements. 3. High resolution EEG technology available that can detect activities of even 1 millisecond. 4. Mostly used as a non-invasive procedure. 5. Easy and simple to use. 3 Disadvantages of EEG. The disadvantages of EEG include 4. 1. The main disadvantage of EEG recording is poor spatial resolution. 2. The EEG signal is not useful for pinpointing the exact source of activity. In other words, they are not very exact. 3. It is difficult to differentiate between activities occurring at closely adjacent locations. 4 Applications of EEG. The applications of EEG include 4. 1. It is mainly used in understanding properties of the brain and its associated areas. 2. When on observation, it helps the doctors to monitor neural patterns in adults and infants. This will help them in detecting abnormalities. 3. In epilepsy, EEG is used to locate areas of the brain and connect them to receive localization information. 4. The feedback system in EEG has ample uses such as in that of psychological, physiological, and/or neurological disorders. This is called EEG neurofeedback. 5. Many disorders as chronic anxiety, depression etc. can be found out using as EEG pattern. V. Processing and feature extraction. Of EEG signal processing involves the following stages. 3. Figure 1, EEG signal processing stages 3. The feature extraction methods of EEG are as follows. 5. 1. Principal component analysis. 2. Independent component analysis. 3. Time frequency analysis. 4. Wavelet transforms. A. Principal component analysis. Principal component analysis, PCA, is a well-established method for feature extraction and dimensionality reduction. In PCA, we try to represent the d-dimensional data in a lower dimensional space. Such a representation would reduce the degrees of freedom and the space and time complexities. 5. The objective is to represent data in a space that best expresses the variation in a sum-squared error sense. To segregate signals coming from various sources, this technique provides to be useful. It facilitates significantly if we know how many independent components exist ahead of time, as with standard clustering methods. 5. A standard PCA when used as a data analysis tool involves a dataset of p number of observations for n number of entities or individuals. These data values define p n-dimensional vectors x1, xp or, equivalently, an n times p data matrix X, whose jth column is the vector xj of observations on the jth variable. 6. Linear combinations are given by plus or minus 1, equals 1, where is a vector of constants a1, a2, ap6. Performance of PCA helps in minimizing the data and time required for computation. It reduces the dimension of the EEG data. 7. B. Independent component analysis. Independent component analysis, ICA, is another feature extraction method. This is used to convert random signals with multiple variables into one with mutually independent components. Individual and independent components can be extracted from mixed signals by using ICA. In this manner, independence denotes the information carried by one component cannot be inferred from the others. 5. Statistically, this means that joint probability of independent quantities is obtained as the product of the probability of each of them. 5. The ICA finds the unmixing matrix, W, and then projects the whitened data onto that matrix for extracting independent signals. 8. Mathematically, A1. Let S equal COV, X, and let X equals as, B equals. Then, B equals WS1/2, 2. For some non-singular W. Then, S equals BX equals WS1/2X with COV, S, equals I and W are orthonormal. 9. Therefore, operationally, equals S1/2X data is sphered and then seek an orthogonal matrix W so that the components S equals W are independent. 9. Independent component analysis helps in segregating the brain and non-brain components from the acquired EEG signal. 7. See time frequency analysis. The time frequency representations, which map a one-dimensional signal into a two-dimensional function of time and frequency, can be divided into two main classes, linear and nonlinear time frequency representations. 10. The linear methods include the short-time Fourier transform, STFT, and Wavelet Transform, WT. The nonlinear methods include the Wignerville distribution, WVD, the exponential distribution, ED, and the reduced interference distribution, RID. 10. For a function, its Fourier transform is given by -2 caret equals 3 dash, where is the time domain or temporal behavior and caret is the frequency behavior. 11. Time frequency analysis involves the analysis of the intermediate signals that combine data of both and caret. It is given by V, where it measures the strength of frequency. At time 11. They provide the right visualization of the EEG waves so as get the various frequency wave bands. 12. D. Wavelet Transforms. It is a mathematical transform that gives the time-frequency representation of the signal. It is an alternative to the short-time Fourier transform, STFT. 13. Most of the feature extraction techniques for classification of EEG waves include wavelet transforms. It is usually used in the there is significant variation between both these set of pre-processing stage. 14. Values. An individual wavelet can be defined by 15. A common type of wavelet is defined using Haar functions. 15. This transform is used for correct analysis of EEG. It could be seizure analysis, neuron potential modeling, etc. 12. 6. Feature extractors. A mean, 17. The ratio of summation of all the values of the signal and the total size of the signal is called the mean of the signal. It is denoted by 1 equals, plus or minus 1. 8. Where is the mean of the signal and x1, xn are the values of the signal. Calculation of mean help in analyzing the weights of various sets of samples of the EEG data. B. Variance 18. Mathematically, variance is a measure of statistical dispersion of a random variable. It is given by where is the mean of the signal. Figure 2, Analysis of Variance 18. The variance helps in comparing the different dispersions of the various sets of the EEG data samples from their means. 17. See Standard Deviation, 18. The measure of dispersion of a set of data from its mean is called standard deviation. It is given by 1 equals v, 2, 10. Plus or minus 1. Where is the mean of the signal? Figure 3, Analysis of Standard Deviation 18. The figure above is a plot of the standard deviation values of normal and seizure-affected individuals. The plot here shows that the standard deviations of the set of values have significant difference from one another. The standard deviation also helps in comparison between the different dispersions of the various sets of the EEG data samples from their means. 17. D. Skewness, 18. The lack of symmetry is measured by the skewness. It is given by equals 1, 3, backslash plus or minus 1. 11. Where is the mean of the signal and is the standard deviation of the signal? The value of skewness gives an interpretation on which side of the mean point the data set is distributed. E power, 17. The measure of amplitude of EEG signal is given by power of the signal. It is denoted by 2 equals 12, where x is the values of the signal and L, x, is the length of the signal. The calculation of power enables analysis of the strength with which the EEG data is occurring. This plays an important role in drawing conclusions about the subject. The figure above is a plot of the variance values of normal and seizure-affected individuals. The plot shows that 7 software tools. The software tools usually used for signal processing include MATLAB, Octave, and SciPy. Of these, MATLAB has always been used as a promising tool for the processing. 19. MATLAB. MATLAB is a software that can be used for algorithm implementation, matrix manipulations, display and plotting of various functions and signals, interfacing with other programs in other languages, etc. EEG can be analyzed directly in MATLAB by writing appropriate. But a more effective and better way of processing EEG data in MATLAB would be using the EEG Lab toolbox. This interactive toolbox enables us to perform various operations on the both continuous and event-related EEG data such as principal component analysis, independent component analysis, 2D plotting of EEG signal, 3D plotting of EEG signal, power spectrum analysis, etc. 22. Neuroview. Neuroview is a software that is designed to record and observe real-time EEG data. Other applications that are used to analyze EEG data can import the information from Neuroview. Programs like Excel can be used to view the data recorded by Neuroview as they are stored as CSV, separate values, files. 23. BCI companies. Brain-computer interface, BCI, devices are used to send and receive signals between the brain and the external environment. BCI manufacturing companies include NeuroSky, Neurovista, Emotive, Neurovigil, Nimi, Alive COR, SHL, Focus Band, Attentive, BioBeats and Jampalamo Foundation, etc. 24 For usage in biomedical and related equipment for easy acquisition and other worthwhile factors, NeuroSky products are preferred. 25. Their products help analyze biometric data in a very easy and practical way. The solutions provided help to motivate people and make their lifestyles better. 26. Think Gear. NeuroSky uses a dry sensor technology. This is used for the measurements, amplification of EEG signals and brainwaves. These are also used to filter and analyze the brainwaves and EEG signals. This technology is called Think Gear. This technology helps respond to person's mental activity aptly. 27. This technology is used in a device named BrainSense by Pantech Solutions. This is a single-channel wireless headset connected to the system using Bluetooth. The activity of the prefrontal lobe is measured at thus acquiring subject's prefrontal cortex EEG data accurately. 28. 8. Conclusion. EEG is a neurological test that uses an electronic monitoring device to measure and record electrical activity in the brain. It is the key tool in the diagnosis and management of epilepsy and other seizure disorders. 29. Interactive MATLAB tools, Neuroview and other similar software are used for processing continuous and event-related EEG, MEG, and electrophysiological data using ICA, PCA and other methods including artifacts rejection. Acknowledgement. We like to thank all the staff of the Department of Medical Electronics and the management of Dayananda Sagar College of Engineering who made it possible for us to come up with this paper.